Hey everyone, and my name is Asya, and I'm in fourth year of my PhD program. And this project is under the supervision of Professor Alexander Cavalcante, who is also my supervisor. Um, I also like to thank to organizers to arrange this kind of the event. It's really informative and know more about technology and integration of technology in teachings, especially at higher level. Um, so. Uh, Around the world, there's growing focus in calculus education on helping students see how abstract maths ideas connected to real situation. And calculus at the post-secondary level is heavy on procedural fluency with little attention to conceptual understanding. So for all the time schools devoted to the teaching of mathematics, very little is spent trying to convey just what the subject is about. Instead, the focus is on learning and applying various procedures to solve math problem. That's a bit like explaining, it's just like a game, like a soccer. I just like to consider in that scenario by saying that in a game, we say like, okay, these are the series of the steps to get the ball into the goal. But accurately describe the various key features, but the missing part is what and the why of the big picture. So, given the demand of the curriculum, I can understand how this happens, but I think it's a mistake, particularly in today's world. A general understanding of the nature, extent, power, and limitation of mathematics is valuable to any citizen. So, over the years, I have met many people who graduated with a degree in such mathematical rich subjects, including myself. My background is in mathematics, and the mathematically rich subjects like engineers, physics, computer science, um, they always told me like they went through their entire school and college level education without ever gaining a good overview of what constitutes mathematics. So when they get into the real life, means the practical, so maybe they can see the true nature of this subject and come to appreciate the extent of its pervasive role in this modern life. So when we talk about the technology in mathematics, so I highly believe in the power of technology because it helps to improve visualization skills, namely the skills of forming visual mental images that are in accordance with the desired outcomes. Technology could be used to improve mathematical procedures. So when we talk about calculus, a visual approach of fundamental ideas of infinitesimals, approximation process, change, variation, accumulation, and so on. So via technology, we can help students gain insights about the formal existence of calculus concepts. And also adding that the students when actively engage, so they can change, they can feel a shift from discrete thinking to continuous thinking with the support of this tool, and they can be more they can more open to analytic thoughts in learning the basic ideas of calculus with this kind of tool. I mean the mathematical software. So this type of thinking involves logical reasoning, critical analysis, and the ability to generalize and adopt concepts to various contexts. Integrating digital technologies help us to understand the world with the lens of mathematics. Okay, so for this project, when I consider mathematical software, so we consider MapleLearn, and the MapleLearn is a simple tool that let us work with math ideas and the problem easily. So it's like a digital notebook where we can write and solve math problems. So without having to remember complicated formulas or code, unlike other mathematical tools, the focus is mainly on graphs and charts. So Maple is designed for taking notes and exploring math concepts in a straightforward way. So when we consider to integrate integration of MapleLearn in calculus, so we consider three main objectives. The three main, so the first is functionalities of Maple Learn. And the second is the relation of Maple Learn and mathematical thinking. And lastly, we consider like the experience when the students use Maple Learn in order to learn various concepts in calculus. So what are their experiences? Another reason that the Maple is, we consider in this project the 5 categories of the functionalities. So those are creation and sharing of documents, natural way of mathematical input, mathematical operation, visualization, and interactivity. So it could be more clear from this slide. So if you see that over here, the red part that indicates uh, the students can create their documents, and from through this share, they can share with the other fellows, or even they can share with the instructors or the other group members, or their the students, those who are working in the same project in the same class. And here is this green box can indicate the math input. It's very easy that the student can easily find what they need to use while to solve any mathematical problem. So this blue part that indicates mathematical operations, and here they can easily see the visual part, they can see the graph, and the most exciting part, which I really enjoy, the sliders. So with this really make a problem very interactive, and this is a most I mean, they can see that how they can see the visually the changes in a graph with the help of this slider. So Maple can help with this by making thinking process in mathematics clearer and more accessible. It allows a student to explore and understand math concept without complicated steps, bringing the underlying process into focus. As students use Maple Learn, their awareness of how math works grow, giving them more ways to approach and solve problems. This increased understanding open up more options and help develop stronger mathematical thinking. So when we talk about mathematical thinking, in my consideration, I considered for the 3 points. Number one is the ability of process of mathematical inquiry, for example, exploration, investigating, and solving mathematical problems or concept. And it involves asking questions, making observations, testing ideas, and finding solutions through logical reasoning and mathematical methods. And second is the confidence in handling emotional and psychological states. And the third is understanding of content of mathematics, and if necessary, the area which it is begin to apply. All right. So for this project, we considered calculus across different contexts, such as social science, applied science and engineering, hard science, and life science. Because this project is in the initial stages, so we just consider at this stage overall calculus across these different contexts with the application of Maple Learn. So this project is mainly focused for first year of university students, undergraduate students. And our research question is how mathematical software can support learning in undergraduate mathematics courses, particularly in calculus. So our methodology was like we selected one university in GTA region, and the students we selected not from the classrooms but from tutorials, and we designed activities with the help of Maple Learn. And in the these activities were based on 3 different days, and after these activities we did a comprehensive observation of students work, both on with the help of Maple Learn and also without Maple Learn, means it could be paper and pencil or this kind of thing, but not without Maple Learn. So The activities we consider exponential function, and I heard like in the one of our morning session talk, I guess Shai Chen, he spoke a little bit about the exponential function. When I started doing this activity with the students they mentioned especially like the exponential function they learned in high school, uh, and in this university as well. At this stage, they think uh, uh, the expectations are different, but we are not learning anything new related to exponential function. So this is a stage I feel like is a real stage to encourage our student to start development of mathematical thinking in students. So at this level, the students are already familiar with various representation of functions such as tables, graphs, or algebraic formula. Um, but this work is intended to enable students to conceptualize function as a global object by coordinating the various representation and connecting functions to other areas of mathematics, including geometry or physics or economics. So, the finding after these activities, they were really interesting. Like I see that the students really enjoy working on their problems with the help of Maple Learn. So the first they can enjoy the both numerical and visual part together. They enjoy working together, and another thing is they really enjoy because they can create their own document and then they can share with their peers, so they really enjoy sharing their work. And the most interesting part is like to commenting on their peers work. um During these activities, because this was like just this project is like in the initial stages, so at the moment we just had 4 students. So out of 4, the one student, he preferred to work with the help of paper and pencil rather to use digital notebook. But also in the end, he commented, using both visual and numerical simultaneously helped to understand concept better, along with creating a community through sharing his or her work. So, however, when using Maple, they actively try to create the same graph. Another thing is like we observe like uh, when they work on a maple, so they start generating their own graphs. They start trying to understand what exponential function is and how they can link with the real in the real world context, or how they can explore in other dimensions. So these functions and how why the exponential functions they are different from other types. So they really enjoy and explore. But another observation was like when they work on a paper, so they were just more focused to just complete problem at the given task. They just like to complete whatever is asked in a question. So, and another interesting thing is they also feel less pressure. They feel like more comfortable environments, and feel more confident. Um, so I so far I heard in this event like the talk about like how to engage students engagement and student thinking, empower the student thinking and social learning. So I feel like the maple is highly encouraged think, pair, and share. So the students um, at the high school, so the many students they are fine at high school working on their own. The best student usually work that way all the time, and including myself when I was in high school. So I was very individual to work. But when I got to university, so I realized the working alone was the worst possible strategy. The reason is mass is like to be as much as we can do the discussion. It's like really give us more sense of think, open up our thinking, and we can, in order to learn the new strategies or the new ideas, the thinking is the best learned by working in a group. So mathematical thinking involves adopting a perspective that views the world through mathematical lens and seeking logical explanation. And student who grasp the element of mathematical thinking can independently use these skills to understand mathematics they encounter. Um, uh, and as we know, our education system is more focused on the limit of completing tasks, or we encourage to work, we have some deadlines, but um, real math tasks really takes time. The main thing to realize is that a lot of what we do probably won't see like doing maths, since the focus is on how to think mathematically, not how to apply standard techniques to solve problems. So we need balance. We need to focus on how to apply different techniques, and also we need to encourage or create an environment where the students can think mathematically. So students also believe, as I mentioned, like they believe like when they come to the university, especially the first year of calculus, they believe that a lot of revisions is from high school. The layout is different, and the method of answering questions, expectations are different. Student feels at the same level of knowledge, only they feel confident in solving questions. So, there we believe that we need to choose questions that require a minimum of mathematical background. Uh, so the learner's attention can be focused away from what they are learning about particular area of mathematics and redirect to the process of fundamental to successful mathematical thinking. So for example, when I read these three different statements, like for example, the man saw the woman with a telescope. So who had the telescope? This really gives to think about critically, like to see like the man or the woman. And similarly, when we talk July in Canada, so it's really comes to be summer. How about Australia? What about Australia, the July? And this is the question that I really like, that if you can take 2 or 3 minutes to use QR code, I will share in the next slide. So what was the first use of number? Measurement of land, money, or tracking the season? So this is a QR code. If you can take 1 minute, maybe you can use it and answer these three. Only one question. That is, what was the first use of numbers?
QR code disappeared.
Oh, okay. Here it is. No, the only I'm looking for question number 3, which is like what was the first use of numbers? So the measurement of land, money, or tracking the season. Okay, so far I received a couple of answers. Really appreciate for that, for the participation. Okay, so another is, I'll wait for a couple of more responses and then I'll see that the majority is for which option, and then I'll disclose the answer, definitely. Okay, season tracking, C part. Okay. Mhm. Okay. Anyone like to add response, or I can go to answer? Mm-hmm. Yep. So, whenever I ask these kind of questions with my students, I always get, okay, here is only 1 minute and you can participate, and other less to. So, okay. So I see the majority is for the option three, the A, that is a measurement of land, and some of you answer like season tracking, and surprisingly, the first use of the numbers was for money. That's a B option. And here is the end of my presentation. And I really encourage, like, if you have any suggestion, because this is just the start of our project. And in the future, we want to consider each context from the calculus that we define into four different contexts, and then consider design the activities for based for each discipline that we categorize. And that's our future plan. Thank you so much.
Thank you very much, Asha, for your engaging talk. So are there any questions? We still have a couple of minutes for the questions. Any comments, perhaps? Anna, please unmute yourself.
Hi. Thank you, Akia. It was really interesting watching this.